Welcome to the Radiocarbon Lab at the University of Ottawa. It's Friday, January 20th, and I'm going to take you through the lab and basically show you how we process samples from start to finish. My name is Carly Cran. I'm a lab technician, and my job is to process samples for radiocarbon dating on Canada's only accelerator mass spectrometer. And my colleague Sarah Morcelli, say hi Sarah.
Hi.
She does the same thing. So the two of us basically process all the samples here. This is the first stage of pre-treatment. So we receive the samples of wood, charcoal, bone, shell, and we arrange them according to sample type. So we get all organized on these sheets here. This is a batch of charcoal, and just to show you, we need very little material. And that's because we use the accelerator mass spectrometer, or AMS. And these are samples of charcoal that we're going to process on Monday. So the first step is to weigh the sample and batch it with your standards. The second step is to bring it into the chemistry area. And so we use this really neat bead bath, which is heated to 80 degrees Celsius. All the tubes get loaded into the bead bath with the various chemicals that they require. So for the charcoal samples, we're going to do an acid rinse. That first acid is going to get rid of any carbonate because the samples have been buried in the natural environment and you can have hard water flowing through the landscape. So we're going to get rid of that carbonate using acid. And then the second step is an alkali or a base wash. So when organic material breaks down, it produces humic acid, and then that gets into your sample, and it's mobile, so we want to get rid of it. So we get rid of that using a base wash, and then anytime you bring the pH up, you can absorb CO2. So we then do the third acid. So this is the AAA pre-treatment, and the second acid, and that second acid basically brings the pH down, and then we don't have to worry about any CO2 from the atmosphere basically sticking into your sample of charcoal. The samples get freeze dried and then brought into the microbalance room for weighing. And we only really need a tiny little bit of material. So it's about the mass of a few eyelashes. And we weigh the samples into these little tin capsules. So for charcoal, because it's 70% carbon or 60% carbon, I'm going to weigh about 2 milligrams of charcoal because that will give us just over 1 milligram of final carbon. So now the samples are weighed. You should grab one of the EA trays. So the samples get weighed. You can just zoom in here. So you can see all of the little samples folded up in those tin capsules, and of course we have our sheet that keeps us all organized. And then they get brought into the CO2 room. So in here, can you stand up and just zoom down on the top of the EA? We put the little tin capsules into this auto sampler, and then they drop down into a furnace and they combust at over 1,000 degrees Celsius. That gas is then purified to remove things like chlorine and sulfur and water and oxygen. Sulfur is the most important thing to remove because in the next step we're going to be getting the carbon from the CO2, because now we're a gas. The carbon is going to adhere to iron powder, and if there's sulfur, then that sulfur is going to take that spot instead. So we make sure we get rid of the sulfur, we remove the water using a water trap, and then the clean CO2 comes out here on the other side. This is a little bit confusing because we're also just doing an experiment right now with combustion of methane, so we've got a lot more set up here than we normally do. But basically what happens is the clean CO2 comes through here, and then using liquid nitrogen, we should use some liquid nitrogen. Do we have any available? Alright. So normally we will have a full tube plugged in here. And when we're ready, we're going to use liquid nitrogen on the end of the tube, and that's going to trap the CO2. So you can imagine this plugged into the vacuum line. I'm just doing this in the room. So CO2 from the room is going to freeze into the bottom of, we call this a brake seal. This is just basically a glass tube. So do you hear that fizz? So if we look now, you can see a little bit of haze on the inside. So that's basically CO2. With an actual sample though, you're gonna have a nice little ice block. And then we light the torch and flame seal the sample. If you watch the other video that I sent, I'm not gonna do a flame sealing right now just because I don't have time. But if you watch the other video, then you can see me flame sealing a whole bunch of samples. And then in the end, we have these nice little break seals. So you can see the glass has just been melted up at the top. So at this stage, you have clean CO2 trapped into a break seal. And they can sit like this indefinitely. So we prepare large batches of our standards. These are machine standards, not standards that go with each batch. Each batch has its own batch of standards. What else? And then we're ready for graphitization. So we have these custom designed graphitization lines, and basically what we're doing here is we're converting CO2 into elemental carbon. So we have our break seal. So this is your, just imagine this is together. And we load the break seal of CO2 into this section of the line. And it's got a little, we've put a little etch on the glass there. And then what we do is we just go like this. And then it pops open the CO2, and then the CO2 can go into the system. We freeze the CO2 and add hydrogen. So your reaction is CO2 plus hydrogen gas. Then we add heat over iron powder. So if we pull this oven off, this is actually running right now, you can see iron powder, which is normally gray, has turned black. And that's your graphitizing sample. So that's your final sample of carbon. The oxygen from the CO2 has turned to water. It's bound with the hydrogen, so now you have H2O. And that water is freezing. There's another tube. If I pull this down just for a quick second, maybe you can see the ice crystals there. See those nice ice crystals? I can't leave it down for too long because we're actually running. But so the H2O is freezing and the carbon's adhering to the iron powder. And as you turn gases into solids, the pressure in the reaction cell goes down. So each one of these reaction cells has a pressure transducer. And if you look over on the screen, this is the pressure of CO2 plus hydrogen. That's the pressure of CO2. This is the pressure of CO2 plus hydrogen. And during the reaction, the pressure comes down. And these samples are actually almost done. I'm pretty much ready to take them off because now the change in pressure is stable. So at this stage, what we have is elemental carbon adhered to iron powder. And then what we do is use these custom pressing modules. So all of this equipment was designed and built in-house, which is pretty amazing that we have that capability. So basically what we do is take one of these aluminum targets and put it into here, and then using one of these funnels, we basically funnel the sample in and then put the cap back on. So now you've got your sample in here, and then it goes over to the pressing module and you press it. And so at the end of this stage, you're going to have one of these aluminum targets with your sample pressed into it. And then we do 200 targets, then they go into here, and then we bring them downstairs to the accelerator. So we'll do a separate video for the accelerator.